Hey everyone, today I'll be doing a short little video on how to use Proteus Analysis to analyze data collected in the Netzsch STA. So this is the screen showing Proteus Analysis. I'll kind of walk you through the main things here that you may want to pay attention to or know about. First, you have the menu bar, in which case you can load the files. Then you'll have a bunch of toolbars, which you'll see will become ungrayed as I open files up and will allow you to manipulate or analyze some of your data, as well as manipulate the main view. On the left side, you will see a tree view of the files, which will show you your files and the segments contained therein. Below that, you'll see an info view where you can view more detailed information about the currently selected file. And in the middle of the screen, you'll see a main view, which will show you your actual data. The first thing I'll do is open up some data files. So I can click the Open menu, and then I'll want to open both a sample and a correction file. You can see the sample files are denoted by a closed circle with the extension SS3, and the correction or baseline files are denoted with an open circle and the extension BS3. So I'll open one of each of those files for the same test. You can see the data has now been loaded into the main screen, and you can see our TG and DSC curves. In the left-hand tree view, you can see that the two files are now present, and then in the one below it, the info view, you can see more detailed information about that particular test. If I click more info, that'll allow us to see the complete information about the test and the data that we put into the header of the file, such as the operator or the laboratory that this was conducted in. First thing I'll do with newly loaded data is typically change the x-axis from a time basis to a temperature basis, which is more commonly used to analyze dynamic or constant heating rate data. To do that, you'll click this button here at the top, which is my most often used toolbar button, which will just switch it from time to temperature. When I do so, it'll warn me that the isothermal segments will be hidden, again, because we are showing a dynamic temperature axis. Any things with constant temperature will necessarily be hidden. So you can go ahead and click that to acknowledge. Now you can see temperature is along the x-axis, and we have our file split in the tree view into isothermal and dynamic segments, again with the isothermal segments being hidden. What we'll want to do now is to subtract our correction curves from our sample. You can do that by either right-clicking on one of the curves within the graph view or right-clicking on one of the curves within the tree view. So here I can right-click on TG, go to Evaluate Curve, Curve Subtraction, and now I'll want to subtract out the baseline. So I can see curve A, which is the one I selected, which you'll want to be your sample file, and then I'll subtract from that curve B, in this case the baseline or correction file. I'll click OK, and now we can see that that curve has been computed. You'll want to do the same for the DSC data. You'll want to right-click, Evaluate Curve, Curve Subtraction, and subtract out that correction or baseline. I'll go ahead and hide the raw TG and DSC signals from the sample as they're no longer needed. I'll also hide the flows from the additional signal as they're constant during the test, and there's really nothing to be gained by looking at them. And then I'll also hide the baseline file, again, as I've now subtracted it, so I no longer need it. Now what you can do is switch the y-axes from a milligram and milliwatt units to percentage and milliwatts per milligram, which normalizes the data to the initial sample mass. This allows you to more easily compare data between slightly varying sample masses. To do that, I'll go to Settings, TG unit, and change it from milligrams to percent. I do the same for the DSC by going to Settings, DSC unit, and changing it to milliwatts per milligram. So now you can see our completed data where we have our percentage and our milliwatts per milligram for our TG and DSC signals respectively, and temperature along the x-axis. There's a couple tools in here I'll point you to that you can use to sort of navigate around the screen that I'll use commonly. The first is a zoom, which, as expected, will allow you to zoom into a particular region of the curve if you'd like to inspect it in more detail. And then the full range button will reset your view to encompass all of your currently loaded data. You can do some basic analysis in here if you wish, although I'll usually do most of that externally. But you can do stuff such as calculating peak values, onset temperatures, or residual masses. One thing that you may want to do within Proteus Analysis is calculate the mass loss rate, or DTG, which is more easily comparable between samples. To do that, you'll right-click on your TG curve, go to Evaluate Curve, and calculate first derivative. You can see that that's been computed now, but the signal is quite noisy, so if you want, you can right-click on that, go to Smoothing, and then input a smoothing value to get a more clean signal. Now I'll show you how to export your data into a format that you can use in MATLAB, Python, or any other external programmer language that you may wish to manipulate it in. To do that, select any one of the curves of your file, go to Extras, and Export Data. You'll now get this little dialog box that pops up along the top, and you can select some of the parameters of your exported data. In this case, we'll want to export the selected file. We'll want to export all of the signals. If you want, you can just select one of the signals to export, but we will want to export all of them for a particular file. We'll want to export the full range of data. If you want, you can select some certain subset of temperatures to export, but there's really no need to do anything except full range. We'll also select to do single points instead of splined. Splined will interpolate your data for you to a particular number of steps, but we'll just get the raw data by exporting single points. Along the right side, you can see options for the format you can choose. You can choose between a Netzsch file, a CSV, custom, or Excel. I'd recommend CSV as the most universally readable file type. By clicking More, you can get some additional options about your exported file. You can export it to a clipboard, which is a copy-paste operation, or an actual file, which is probably what you want. You can also select the character set, which is how the actual data is encoded. That can either be ANSI, ASCII, or Unicode. I would recommend using Unicode. We can then click Export, which will pop up a file dialog, prompting us to save the file somewhere. I'll go ahead and save this file. And then I will view this file so I can show you what to expect when you get your data. So this is the CSV file that is export. You can see along the top of the file, we'll have a bunch of header information that will contain the metadata about the test, such as the sample name, the operator, and the conditions over which it was conducted. Then below that, you'll see the actual data itself. In this case, we'll have columns for temperature, time, mass, DSC, DTG, and sensitivity. You can see that the units of these columns are percentage in milliwatts per milligram as we change those in the settings menu. I hope this was helpful to teach you how to use Proteus Analysis to analyze some of your data collected in the Netzsch STA, and you figured out how to export the data to be able to use it in some external program or plot it in some other program. Thank you very much, and I'll see you in the next video.